What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video I'm going to show you how to find the average rate of change of a function over an interval by being given either the equation that defines the function or the graph of the function. We're going to look at both types of examples. First I'm going to try to help you understand this concept. Here's the definition. The average rate of change of a function over an interval is how much the outputs or y values change on average per unit over the interval. If this last part doesn't make 100% sense, that's okay. We're going to go through some examples and that should help solidify it. But honestly, I found that average rate of change is a really easy thing to find. It's a pretty simple formula. Kids are pretty good at that. But it's kind of a difficult thing to understand. And so that's my goal with this first example here, which is why I gave it in context. We have a Sunday bike ride. Our x-axis represents time in hours. So this was a 4-hour bike ride. And our y-axis here represents total miles traveled. So this was a total of a 36-mile bike ride. Super impressive. We are asked to find the average rate of change over the interval 1, 3. And this is sometimes stated as from x equals 1 to x equals 3 or from 1 to 3. So there's different ways to say this. Just keep in mind that the interval we're given is always x values, some change in x. So we are starting when x equals 1. That's 1 hour into the bike ride, and the person has traveled 8 miles total at that point. And we want to find, on average, how much do the y values change from 1 hour into the bike ride to 3 hours into the bike ride, which is at this point here where the person is 24 miles into the bike ride. So remember, that's our definition, is on average, how much do the outputs change per unit over this interval? Well, it might help to find the total amount the outputs change, right? This total change in y values. So what do we add to 8 to get 24? That's how very often kids think about it, which is great. Or we can write it as subtraction, 24 minus 8. And I'm going to write it this way because that aligns with our formula that I actually gave a sneak peek of on the front page. So 16 is the total. That's the total change in y. The y values have increased by 16 from this point to this point. So since we're trying to find an average, we want to do some division here. On average per unit. What does that mean? Well, this person traveled a total of 16 miles, but across how much time? 2 hours, right? From 1 hour into the bike ride to 3 hours in the bike ride. 3 minus 1, that is a total of 2 hours. So an average per unit means we are looking for miles or average miles per hour, right? So on average, how many miles per hour did this person travel from 1 hour into the bike ride to 3 hours into the bike ride? And that is 8. 16 divided by 2 is 8. And we could even think of it as 8 over 1. Sometimes that's helpful, miles per hour, because the 8 over 1 helps us think of this as a ratio. 8 miles for every 1 hour. And we got that by simplifying. 16 miles across 2 hours is an average of 8 miles per 1 hour, right? And we can see that. Hopefully that makes sense in this context. And that's what this per unit piece means here. And this really per unit only makes sense when the x-axis has an actual unit, like hours. If it doesn't, like for example, if this were not given any context and we were just given this graph, then it wouldn't be miles per hour. It'd be kind of, what's the word, abstract, right? It would be like the y values increase by 8 for every increase in the x values by 1. So really abstract, but that's still a really helpful way to think about it. And here's what we just did. We subtracted the two y values and we divided by the difference in the two x values. This should look very similar to a slope formula that you learned when you studied linear equations, and we're going to actually make that connection in the next example. But we found from the interval 1, 3, and so this was f of 3 minus f of 1. Right, this y value minus this y value, and this was 3 minus 1, the difference in the two x values, and that gave us average rate of change. So hopefully that example made sense and helped you understand the concept a little bit. Let's jump into one more here. We have another function, this one without any context, and we're trying to find the average rate of change over this interval from 4 to 16. Remember, these are always x values. And so now let's just apply our formula here. So remember, our formula is f of b minus f of a. That's just the difference in the two y values, or the two outputs, divided by b minus a. So let's write it out. What is f of b here? That is 0. right? Remember, that's f of 16. We have a and b. So that's 0 minus, what is f of a here? That's f of 4, that is 12. Divided by 16 minus 4. And so this equals, in the numerator, 0 minus 12 is negative 12. Divided by 16 minus 4 is positive 12. And this simplifies. 12 over 12 is 1. We have this negative just hanging out. And so this equals negative 1. And what in the world does this mean? Let's go back to our definition. Actually, yeah, here we go. What does this mean? This means, on average, the y values decrease by 1. On average, remember, the y values decrease by 1 every time x increases by 1. Right? So again, we could think of it as a ratio. If I want to write this, negative 1 over 1, that's how we always think of it, unless it's already a fraction. If it's a whole number, this is helpful, because that's what this means. On average, the y values decrease by 1 every time x increases by 1. Right? And that should make sense, because over a distance of 12 from 4 to 16, the y values decrease a total of 12. And again, this change in y divided by change in x may seem really familiar. It may remind you of slope, and that's actually exactly what this is. If we draw a line through here, what is the slope of this line? It's negative 1. What's the rise over run? Well, we go down 12 and then over 12, right? We have rise over run here. And so this leads us to a really important connection between average rate of change and the slope of a line. And this is called a secant line. A line that intersects 2 points, that goes through 2 points on a graph like this, is called a secant line. And what we can conclude is that the average rate of change of a function over an interval is the slope of the secant line that connects the 2 points, right? So we have this secant line that's connecting these 2 points. The slope of this line is exactly the average rate of change. And that may help us to think about average rate of change, or even identify it when we're given graphs like this or graphs like this. We could have drawn this and we could have found the slope. What's the rise over run? Up 16 over 2. 16 over 2 is 8 miles per hour. Hopefully that's making sense. We practiced from a graph. We made the connection to the graph and the secant line. So now let's do a couple of examples where we're just given functions like this. Find the average rate of change of this function over this interval. So kids tend to have a pretty easy time with this because they just remember the formula. They identify this as A, they identify this as B, and then they say, oh, okay, f of B, you can even write it out if that's helpful. F of B minus f of A, they know that these are y values. And then B minus A, they know those are just given to you. That's just 2 minus negative 1. So first we need to find f of B, which is f of 2 in this case. And then we need to subtract f of A, which is f of negative 1. So what do I get when I plug 2 into this function? Let's find that out. F of 2 is 2 squared plus 2 times 2 minus 3. 2 squared is 4. 2 times 2 is 4 minus 3. So what do we have here? 8 minus 3 is 5. Boom. F of 2 is 5. So that was f of B that we just found. Now let's find f of A. F of negative 1, what is that? Negative 1 squared, don't screw this up. Negative 1 times negative 1 is 1. Plus 2 times negative 1, that is minus 2, and then minus 3. So we have 1 minus a total of 5. So 1 minus 5 is negative 4. Bada boom, bada bing. Awesome. All right, so we have 5 minus negative 4 in the numerator. 5 minus negative 4. Don't screw this up either. Write it all out because that's going to become 5 plus 4, or be equivalent to it. And then we have 2 minus negative 1 in the denominator. So our numerator is 5 plus 4, that is 9. Our denominator is 2 plus 1. Remember, minus, you can do boop, boop. 2 plus 1 is 3. This simplifies. 9 divided by 3 is 3. And what that means is that this is the average rate of change. On average, for each increase in x by 1, the y values increase by 3. And that's just an average, right? So this is a parabola. It looks something like this. And so we probably, in this case, have something like this, where we're going from like here to here. And as the x values increase by 3, the y values increase by 9. In fact, let's check it out. Boom. That's exactly what we have. So we can see that this is the slope of the secant line. It's 3. That's the average rate of change over the interval. For a second, I forgot I included the graphs in this video. All right, one final example. Here's your check for understanding. This is the point where you pause the video, pull out your scratch piece of paper, try this on your own, and press play to check your answer. See if you got this down. This will probably be on your test. All right, hopefully you got the answer in front of you. You're just checking your work. So remember, we are finding f of 8. We are subtracting f of 3. And then we are dividing that by 8 minus 3, which is 5. So off to the side, we can find f of 8 first. And that's equal to 2 times, what is this, 8 plus 1? Oh, square root of 9. Amazing. Plus 3. 9's a perfect square. Makes it easy. 2 times 3 plus 3. Make sure we follow the order of operations here. 2 times 3 is 6. Plus 3 is 9. Amazing. And then we have f of 3. F of 3. All right, when we plug that in, what do we get? Square root of 3 plus 1, that is 4. Plus 3. 2 times square root of 4, that's 2 times 2, that's 4. Plus 3 is 7. So I'll write it all out here. 4 plus 3 is 7. So in the numerator, we have f of 8 is equal to 9. Okay. We have f of 3 is equal to 7. And in the denominator, we have 8 minus 3, and that is 5. So we have 2 in the numerator, and we have 5 in the denominator. And there are 2 different ways we can interpret this. One is, for each increase in x by 5, the y values increase by an average of 2. That's one way to think about it. The other way is, for each increase in x by 1, the y values increase by an average of 2/5. Second way to think about it, and we can support this by looking at the graph, connecting it again to the slope of a secant line through those 2 points. And that's all I got for this video. Hope it helped you. Just a few examples. This isn't that bad. Probably what you're going to be asked to do on a test is something like this, where you give it an actual function to plug stuff into, or maybe something like this, where you can actually just draw a line. You can find the change in y, change of x. So hopefully this video helped. If it did, make sure to like it. Any questions you can leave in the comments below. Do all this stuff to support me. Subscribe. Find me on TikTok and Instagram. But most importantly, keep flexing those brain muscles, and I'll see y'all later.